Hi there. Today I've got a Pioneer SX-850 that has come in for a suspected warranty claim. This originally came in 2020 for an output stage failure and a good cleaning. It had been stored for 20 years and was inoperative. It wouldn't come out of protect. And the guy originally had some other person look at it. Okay, they actually did a little bit more than look at it. I kind of tampered with it. He tried his best, but wasn't able to fix it. Anyway, I found one output stage, I think it was this channel actually, that was shorted, and the other stage had really high bias because of said tampering. So I actually had the guy let me rebuild both sides just so we could be sure that everything was going to be fairly durable. As I said, they were both in the same environment, and as I said, the other output stage had been kind of abused because its bias had been cranked through the roof. So we did that. I also had him allow me to recap the regulated power supply. There were some capacitors that were just visually bad. It was obvious they were bulging and one of them was leaking, so pretty obvious there. That actually took care of a hum. And while I was in there, I replaced the 6 capacitors on the protection circuit because the protection circuit has to be lifted up to get at this board. And the protection circuit's really important because not only does it protect the amplifier, it protects your speakers as well. But anyway, long story short, it's back in the shop here in 2021 for the exact same symptoms. No audio, and it won't come out of protect. Now right now, Andrews Electronics is closed for a shop move, but we will move metaphorical mountains to accommodate warranty repairs, much as we would certain types of expedited emergency repairs. So, one of the first things you want to check on anything that doesn't work is just kind of look it over. Is there any physical damage? Do you see burned fuse, any blown fuses, burnt components, stuff like that? And in this case, no broken circuit boards, no out-of-place wiring, no blown fuses, no burnt resistors, no scorch marks. The chassis is fine. Doesn't look like it's been dropped or anything like that. Doesn't look like it's gotten wet. Everything looks peachy. So now, with the physical inspection out of the way, I can pretty confidently say we can do electrical troubleshooting at this point and do it fairly safely. Within, of course, the typical common sense guidelines, like not touching that. That will shock you, obviously, because that's the mains. And of course, some of the other power supplies in this unit are also fairly high voltage and not exactly safe to touch. Well, whatever. We can certainly avoid those hazards. So one of the first things we want to check on a power amplifier that won't come out of protect is, do I have any massive DC offsets? And the easiest place to look when you have an amplifier like this where the protection relay is easy to access is simply look on the input side of that relay as the signal is coming out of the amplifier. And we can actually trace those signal wires coming out of the amp, and they go right to the relay here. And we'll check one channel with respect to ground, as this is ground referenced output. Wow, massive DC offset. And we'll go to the other channel, and we'll find that it's basically the same. Well, that's not good, but it's also kind of weird. So, massive offsets when you have a shorted output stage, that's common, but usually you won't see 14.5 volts. Generally, you'll see the full supply voltage of one of the supplies, and in this case, the supply voltage is about 46 volts, plus and minus. So we would expect to see 44 to 46 volts, somewhere around there, at the output if it were a shorted output stage, and we're not seeing that. Additionally, normally only one side fails in a stereo amplifier because they're symmetrical circuits and they're actually independent in most amplifiers, and they have to be independent to some extent, but in this case it's actually fully independent. They happen to be on the same circuit board, but you can actually just split it right down the middle. So that's really fishy for both of them to be malfunctioning in the same manner. So let's widen our scope a bit. Let's think about, well, what common thing could cause both channels to mess up in the exact same manner? Well, power supply. So we've already proven that the main power supply to the power amp is okay, but there's actually another power supply in here that runs the input stage, and it's provided by this regulated output. Now, at the time, I did not know where that was going, and it's kind of a rat's nest to trace, and I didn't know which wire was what. So what I did was I just kind of intuitively thought, okay, this is the power supply board right here. Most of these output wires should be not ground. And I figured, okay, the black ones are probably ground, as they are in most Pioneers, and I checked that, and yeah, there's 0 volts there with respect to ground. I got 5 volts there. I've got 13.6 there. I've got 13.6 there. I've got 50.9 there. So a lot of these pins should have voltage, but then when I got to pin 8, 9, and 10, I found that. Now that's a lot of pins to have just negative 1 volt on there. And the other thing about 1970s circuits is they require more voltage than that. That might be a signal level, but that wouldn't be a power supply. Something's fishy here. So, thinking I have a power supply problem, I go, okay, well, what voltages do I know I should have? And then I got a brainwave. I'm like, okay, the protection relay is 24 volts, so therefore the protection circuit must have 24 volts on it somewhere. Or at least 24 volts, maybe more. So we'll just go and test all the stuff. And I'm doing this because I note that on one of those orange terminals, it goes directly from the power supply on one of these orange wire terminals to the protection circuit. That's probably our high output offsets right there. But again, no 24 or more volts to run that protection relay. And this is the circuit that determines whether that relay is going to be powered up or not. So naturally, it's switching that power, so it has to have 24 volt power somewhere, and it doesn't. So clearly, I don't have a power supply. I've got a power supply down in here somewhere. What I didn't realize was just how much stuff that actually powers up. When I actually looked at the schematic, I found that pins 8 and 9 with respect to ground should have 36.5 volts on them, and that 36.5 volt supply powers up the following items: the tone control amplifier, half of the flat amplifier, the protection circuit, which explains our missing relay voltage. It indirectly powers the phono stage by way of a 28 volt regulator that is fed by that 36 volt regulator, and, drum roll please, the input stage of the power amp, without which the circuit will be hopelessly out of balance and give you massive offsets. So that very neatly explains our problem. Now, is this covered under the customer's warranty? Unfortunately not. It's outside of the scope of the original repair and is thus not warranted. However, since we've gone and done all this work, it's actually going to be fairly easy to replace the defective component. And I did some tracing here, and sometimes the tracing is actually easy on some of these units because they've actually got the silk screen of the underside trace mirrored on the top, so you can actually run some tracing. And I traced it down to this transistor here. And that transistor is Q5, and that's responsible for regulating the 36 volt off of a higher voltage regulated supply. And Q5 has gone open circuit on me. So that's it. So replacing Q5 is not that difficult. You just simply pull up the protection board and then pull this up, fold it out, and once it's folded out, you can just desolder Q5 and put a new transistor in there. I'm not going to use the original part number. That part is unavailable, and it's not really picky about what kind of transistor you use. As long as you get something of similar rating, it'll be fine. I'm also going to replace its mates over here, simply because it's the same type of transistor and similar service. They might also be on the way out, I don't know. And I want the customer to have the best experience possible. What the customer is not going to pay for, however, is any expedited service fees. If I decide to take on a warranty claim and it ends up not being warranted, I eat that expedited service fee because I was the one that told you, hey, bring it in for warranty. So I'm not going to get to claim that, but that's fine. How much is this all going to cost to repair? Probably about $50. $45 diagnostic fee includes the first 30 minutes of labor, and this is going to be about 30 minutes to repair. It took about the length of this video to diagnose the problem, and it'll take about 20 minutes to change out that transistor, I'm thinking, so it's not really a big deal. If it goes over, I'll cut the customer a break and just say, little gift. Thanks for being a good customer. It is unfortunate that the customer had to come back this soon, though. And you're probably wondering, well, why didn't I change that transistor anyway when I was in there? Well, it was a little out of the scope of the amount of services he wanted to get. He wasn't getting a full restoration. It was just simply a repair and a cleaning. So it's all just like, okay, how much you expect me to do on a repair? I'm not going to rebuild your entire unit on just a repair, so sometimes stuff like this happens, but it's fairly rare. So it happens, it's unfortunate, but at least it's an easy fix. So pardon the background noise. We're having a bit of a thunderstorm rolling through right now, so I'm going to get this guy fixed up and get it out of my shop, and hopefully a customer will be really happy with it for years to come. I don't think anything else is going to break in here. Everything else looks pretty good, so I'm not expecting any additional faults to be found either. I'm 99% sure that this is the sole fault in the unit, and it does very neatly explain all the problems that we're having in here. So without any further ado, I'm going to replace that transistor and see you on the next repair. Thanks.